DC Builder with us, who's a research engineer at the World Foundation.
Text generated by AIs, images generated by AIs, videos generated by AIs would become indistinguishable from reality. So you need to have a way to tell apart humans from non-humans.
30-second overview of World and what you're building.
The first product was the Orb. The Orb is a hardware device which scans people's irises, and it's able to compute this thing called an iris code. The Orb itself has like specific auditing mechanisms built in, and you can load it onto your computer and you can verify like that the source code is matching a build from this open source repository. There's nothing added to it.
So on the AI side, what are you seeing in terms of the biggest impacts for World?
One of the negative outcomes of this would be the dead internet theory, where the user experience of the internet becomes so bad for humans that nobody wants to use the internet anymore.
Hey everybody, welcome to the Web3 Security Podcast. Today we have DC Builder with us, who's a research engineer at the World Foundation. If you're not familiar with World, it is a global network for human verification to basically distinguish humans from bots, co-founded by Sam Altman, has over 17 million unique humans on the platform across 160 countries, more than 38 million app downloads. I think it's one of the most used crypto apps out there, and approaching 1 billion wallet transactions on the network. Hopefully those are the latest, most impressive stats, but those are extremely impressive stats. So great to have you with us, DC, and thanks for joining.
Thank you for the introduction, Jack. Well, happy to be here.
Awesome. So let's dive right into things. You've got a super impressive background and kind of pedigree. So we'd love to learn, like, from the very beginning, how did you get into computers and what got you interested in technology?
For computers, I guess the first time the first ever exposure was to video games. So I've been a gamer my whole life since I was 5. I had the PS2, then the PlayStation Portable, the Wii, and et cetera, et cetera. Like, I played games. So eventually I graduated from console games to PC games, through like Minecraft and eventually League of Legends as a young person. So that's like sort of my first entry to computers. But into computers as a technology and like computer science and maths and things like that. I was probably in like the last year of, in the Czech Republic, it would be primary school, but in the US would be known as like middle school, like 9th grade or so. I got interested because like one of my teachers just showed us like a very simple class on like HTML, CSS, and JavaScript programming, just like very basic websites. And I was already like used to seeing like tutorials for video games on YouTube. So it was a natural tendency to just like, if I didn't know something, I was just search it up on YouTube. And so after I got curious about it from school, I just searched like JavaScript development tutorials on YouTube. And I found this website called Free Code Camp. And I started learning like JavaScript and just very basic front-end web development. So that's the very, very beginning. After that, I discovered this also YouTube series called CS50. So Harvard University has this professor called David J. Malin. And they run a course called CS50, like a very introduction to computer science, very for beginners course. And so I did that on Coursera/YouTube. And that was like my very, very, very beginning for computer science and computers. Yeah. It went down from there, like a rabbit hole.
Awesome. Yeah. Familiar with Free Code Camp, familiar with that CS50 class. Didn't take the whole thing, but I know exactly what you're talking about.
I was like 14, 15. I was around that time. Yeah.
You were 14 or 15 years old.
Yeah. Mm-hmm.
Yeah. Wow. Yeah. That's pretty young. That's impressive. And so where did it go from there? When you were in high school, did you continue programming or playing around with these things?
So I got to high school, and of course I was still learning like the like full stack at that point. Like I went from vanilla JavaScript to jQuery, which was still a thing back then. From jQuery, then the first like few frameworks popped up, like CSS, Bootstrap, Sass. Then JavaScript frameworks came along. So the first one I learned properly was React. And so React, then into TypeScript. So like I was really excited about full stack web development, start learning about like things like databases and CRUD and like full stack web apps. And then you learn things about like Node.js, like backend stuff. So that was like the very beginning. And then I guess the biggest change I made, or the biggest like new thing that got introduced to me, was I was watching. I was really into like maths, physics, in high school. Also because of other YouTube channels like Khan Academy, and like websites. Khan Academy like is like a foundational thing. And also I discovered Three Blue and Brown. I don't know if you know Three Blue and Brown. He
Yeah.
is Grant Sanderson, great guy. He makes like these wonderful mathematical animations, showing things like differential equations or calculus or linear algebra. So I got excited about that. I guess since the YouTube algorithm knew I was into maths, they started showing me like CES demo videos, like the Consumer Electronics shows videos. And in 2015 or 2016, when I was like 15, 16, I watched this video from Jensen Huang at CES presenting Nvidia chips. And he was showing this like a robot machine learning model was trained inside of a virtual environment to perform some task. And then they loaded the same model into real robots, and the robot performed the task in reality. I think it was like some surgery on a grape. I vaguely remember something like that. Like it was a robot trained to do surgery on a grape in a virtual environment. And then it proceeded to do it in a real environment. So my mind was blown as a teenager. And so I got into like a robotics class, I guess, at high school, like an extracurricular like activity thing that was part of the school. And we like programmed like Lego robots, like Lego EV3. It's discontinued. I don't think they make them anymore. But that's sort of like, I got excited about like machine learning. And so again, I went on YouTube and started learning machine learning. And I realized there's a lot of math. I didn't understand any of the code. It was Python. So I learned Python. That was more straightforward because I knew full stack. And then I started learning the math. So I went into Khan Academy and through Blue and Brown and learned like the proper math for it. And then I took this course from Andrew Ng on Coursera, who is like an introduction to AI and machine learning course. And I started just learning like the frameworks for Python for that, like the basics data analysis ones. So like pandas, NumPy, scikit-learn, matplotlib, like all the graphs making one. And then from there, basic PyTorch, which is a very popular, like the most used ML library, I would say. And I joined a startup in my local area that was making like some AI tools for agriculture, where they had drones fly over crop fields and they took pictures of them. And the agricultural people, like the statisticians from the government, they're interested in seeing like grain density. And that's sort of like how you measure yields of crops. And so they took pictures of these fields using drones, and then they analyzed using machine learning, counting like the different heads of the wheat. I don't know how you say it in English, like wheat strands, and they counted like how many different wheat heads there were in the field, and that's how they automated like measuring yields of crops. Because otherwise, you had like a kid that was like 15, 16 go out to the field and manually count, like, and then just like try and infer how many of them there were in a specific area. And so we built the model that counted that, and also some other like various like agricultural tasks, like measuring how many grains there are per one. Like you just had like a Raspberry Pi inside of a box that took a picture of just like a holder that you put like a bunch of grain on. And you just measured how many grains there were on this holder, and the Raspberry Pi would take an image and just count how many grains of a specific thing there were. So this is like my first job. And so that's how I sort of got interested into machine learning. Yeah, that's sort of like the machine learning journey. And then crypto, for me, I learned about crypto soon after, because again, Three Blue and Brown made a video about how does Bitcoin actually work, I think in 2018. So it was a very introductory video into like proof of work and consensus algorithms and hash functions and private public key or asymmetric cryptography. So that was like my first ever introduction to Bitcoin. And so then I got interested in that as well.
Wow. Before we get into the crypto side, I mean, what you're describing, a lot of it is online tools, really, like online courses and that sort of thing. And, you're based in the Czech Republic. Is that right?
Yep. Mm-hmm.
Were there other kids like doing these things along with you, or were you pretty much on a track that was completely separate?
I was definitely like raised by the internet, and like a lot of the community I found was online, but there were a few kids, especially in this robotics class I mentioned, that shared like similar enthusiasm for these things. So I had like 2 or 3 friends that knew how to code. And so we did a bunch of these things together, or we would share these things. I also became a Linux fanatic because my Windows computer was dying. And so I just saw on a forum, if like you want to salvage your computer, just install Linux on it. And so my Windows computer would not work with Windows. So I just flashed Ubuntu on it. And so I went down the rabbit hole of Linux as well. So I went from Ubuntu, which is a very vanilla distribution, to Manjaro, which is sort of like more like half standardized, half you can like customize things. And then I got into like tiling window managers where you can like, yeah, it is this like way of rendering windows and like organizing windows on your computer. And so then I went to this like stereotypical Linux distribution for the nerds called Arch Linux. So I started, like compiling my own Linux kernel and stuff. It was like, there's a few people around me that were interested, but I was mostly like learning things from the internet, then sharing with friends in person. So there was definitely like this also like good reinforcing function in reality, which is good.
Yeah, got it. Okay, that's really cool. And so you were on a path. I mean, you were on a robotics path, an AI path, and maybe a little bit of a crypto path. How did you end up, getting more into the crypto side?
Yeah, that's a great question. So I actually wanted to go to the US and study AI machine learning at university. So there was 3 paths for me that I had seen at that point. One was physics. I was really into physics. So, and I did a few camps, like physics camps in the Czech Republic while I was at high school. And so one specific field of physics that I liked was like particle physics. So I was planning to study like theoretical physics and then focusing on like particle physics at the Charles University in Prague. That was one option. The second option was studying machine learning. But for machine learning, if you wanted to get good, you sort of would have to go to the US because like all the major companies and major jobs that I had known of was like Google or Facebook or some other company that actually had production ML, because this was like 2018. Like there were very few production ML use cases in 2018. There was like some computer vision stuff, some spam filtering stuff. There's some CNNs, like very early CNNs, like distinguish this is an image of a cat or dog kind of CNNs, like very basic stuff. I was like listening to some podcasts and stuff. There's like some really good podcasts back in the day as well. So like they mostly talked about these companies. So like the way I thought of the future is like go to a US university and then go to a US like top like tech company. But the problem with that was that I'm not from a wealthy family. I'm like middle class, grew up middle class. So going to the US from a middle class Czech family is not very like economically feasible because you have to get like financial aids, and it's really hard to get financial aid as a foreign student. So I would have to be like really top of class. So I was training on Khan Academy to like take the SATs. I wanted to go to the US. But in the end, I realized that it's likely that I will get the same quality of an education in the Czech Republic. And I can just try hard for making up the financial difference of not being able to be in the US, right? They can learn from the internet because the other kids were not learning from the internet. So I had that advantage, like the self-driven, self-motivation. And it was just fun.
Right.
It was just intellectual curiosity driving me mostly. So I decided to stay in the Czech Republic and I joined like theoretical computer science with a focus on ML. And so at 19, I went to uni, like in Charles University in Prague, but then COVID hit. So everything was remote and I didn't go to school. Like I've never been at uni in person. I was enrolled at the university, but we had Zoom classes for the first semester. And we were learning like, it was the first year that the university switched from teaching Pascal, a language from the like 70s, 80s, to switching to teaching Python. But they were teaching Python as if it was Pascal, right? So the things like formatting or like standards, like I had already written Python before because of the ML stuff. So in Python, there's this like standard called PEP8 for like how you should like style functions, how you should like break up modules, et cetera, et cetera. I was like, these people do not know how to write Python. So the only thing that I was learning there was like the CS mathematics side of things, which I already thought that I could learn online because all the tooling is there, right? Like all the like MIT OpenCourseware lectures on advanced linear algebra or calculus or differential equations, whatever have you, like is online and with better teachers, arguably. So I was like, this is not for me. So I decided to quit university. And another factor for quitting university after the first semester for me was I had a job before as like a front-end developer, and then this like ML job for these like convolutional neural networks for like detecting the agriculture stuff. I found a job on YouTube. So I had already been interested in crypto back then. And so there was this YouTuber called Ivan on Tech. Back then I didn't know Twitter. I didn't know that everything was on Twitter. So I just found YouTube videos. And this YouTuber had an academy for learning crypto stuff. It was called the Ivan on Tech Academy back then. And so he had a job posted on Ivan on Tech Academy through YouTube. Like he was on a YouTube video saying like, hey, we have this job at the academy. And the title description was altcoin researcher. So the job description was essentially, hey, research altcoins and write about them. Like how do they work on a technical level? Like what consensus algorithm they use, what programming language, like how does this DeFi protocol work, and what the token associated with it is. It's sort of like a very vanilla version of like a Messari or like the block or like some news info, whatever thing. And so I wrote articles. I started writing articles. I got the job after applying. And I started writing articles for this company. And so I was like a 19-year-old making like 3x or 4x what an intern in the Czech Republic would make at a remote job working for the Swedish company, because Sweden, Czech Republic, like average quality of life or like economic parity is like much higher in Sweden. So yeah, like I had no incentive essentially to stay at university because I was making more per hour than the graduates were making at like entry level positions. So it was like, it's just a good reason to go full-time crypto. And also like on the sort of value alignment side, crypto appealed to me because of this, like the way I got into Bitcoin is from like the fundamental side of it, like modern monetary theory, the Fed printing money, devaluing your assets, you losing purchasing power, and sort of like hard money. I got from like the hard money angle into crypto. Plus the technological side was super interesting, like the maths from Fibor and Brown, hash functions, etc. So on a value side, for the decisions I had to make, I didn't want to go to the US to work for some big tech company, which just the sole incentive was like financial, like making money as a big company. But like I didn't understand like products or entrepreneurship back then like I do now, but I just didn't want to work for something like that. And crypto seemed like this open-ended positive sum technology, like full of super new things. And I also knew that there were a lot of really smart people already working in AI. So it's a lot more competitive. Like there's already super smart PhDs working on it. Whereas in crypto, you felt like as a 19-year-old, your output was far more valuable than in AI. And also the entry bar was a lot lower. So you could know a lot less and still be useful and still be economically rewarded for it, and a lot more faster growth curves. So that's sort of like what appealed for crypto, like the value side of this like freedom, positive sum, collaborative, open source, decentralized movement versus this more like top-down corporate, because it was only like 5-6 companies that were making AI stuff back then. So that's sort of like why I went crypto. So I joined Ivan on Tech Academy full-time after I quit university. And that's like the origin story of like why I went full-time crypto.
Wow, that's super cool. And really cool that there was a like positive impact angle to it as well. The hard money, very impressive at 19 to be thinking about those aspects for a career.
I feel like I wasn't thinking about it from like the I want to make money side. Is more of like intellectual curiosity. It's always like, this is fun to learn about, or this is fun to do, or to write about, or to. I think people underestimate, like, I don't know how to say it. Like, it wasn't some like crazy vision or something. It was just fun. So it's like endless rabbit holes of learning more and more about things that are fun or interesting. So that's mostly like how you get to these things when you're young.
Yeah, totally makes sense. Okay, and so how do you get from altcoin researcher at Ivan on Tech to World?
So Ivan on Tech eventually, or Ivan, founded this company called Moralis. Moralis is like they're still around today. They're like a Web3 development SDK company. They provide like nodes and APIs for indexing Ethereum, other chains, and they provide like data analysis tools and developer tools. And so Ivan on Tech Academy became Moralis Academy. And I was there for about a year and a half to 2 years. So I was like 21. when I decided to leave. The reason for that being is like after writing articles for 2 years, I felt like I had nothing more to learn from being around the people that I was at Admiralis at that point. So I started publishing articles as myself. So I created this like online persona. I already had discovered Twitter through writing articles because everyone was telling me like, hey, there's these people on Twitter talking about these things and they know more people than like YouTubers, for example, which I was looking at before. Um, so on Twitter, there's like a lot of like really smart people. So I started learning from them and I started like getting into this like anon culture. There's like some really cool anons that I was following at the time. I don't know if you know 0x
I haven't heard that in a while, but I remember. Yeah, I remember
Zero
Tuba.
to zero to like anime girl profile picture. So he was like writing articles, or like she, I don't know who he is, writing articles about like DeFi and stuff. So like I was talking to them, and they gave me sort of like the original inspiration for like becoming anon. So I created this like anon personality called DC Builder in 2021, end of 21. And I started writing this article about layer twos called The Ultimate Guide to L2s on Ethereum. It's still up there somewhere. It was on this
I
platform
saw it.
called Mirror. I don't know if you remember Mirror.
I do. I do.
It's now Paragraph. I guess they merged or got acquired or something. The Ultimate Guide to L2s on Ethereum. So that article is sort of like my first jump or venture into like crypto Twitter. Yeah, let me just find the date. It was October 22. So prior to writing this article, I went to my first Ethereum conference, Ethereum ETH Lisbon in 2022.
Nice.
And I met the L2 beat people and I asked them a bunch of questions about L2s. And as I was writing this article, I met the Optimism guys. I met just so many other L2 people back then. I met the Aave team. They also invited me to Finland, to Helsinki. It was super nice team. And so back then I started, for the first time, I started meeting the people that I had known on Twitter from being an anon. And I wrote this article soon after that conference. And I met so many nice people. And that was like sort of my first start, where I started meeting people and I started sort of growing professionally. And I was starting to do like more fulfilling things. The first job I got was actually at ETH Denver the following year. So the first time I ever went to the US was ETH Denver 2022. It's November 14th, 2021 was when I published the article. So the Ultimate Guide to L2s was in November of 2021. So it's over 5 years ago. That time flies. So I published that article in November. And in February of 22, I went to the US for the first time to ETH Denver. I met so many people there. We had this, do you know Jessie? She now works at DEF on AI stuff.
I'm not sure I do.
So Jessie, she goes online as 13-year-old VC. Maybe that's her handle. Maybe you know it as that.
Okay.
But she created this like hacker house in Denver called Jessie's Hacker House, and it was like a series of hacker houses. So I gave her, or I tweeted online or Twitter, like, is there someone doing a hacker house in Denver? And this random person, which ended up being her, tweeted, hey, I might do something. So I gave her the idea to create like the series of hacker houses. And then like me and a bunch of like kids in crypto applied and got accepted. So we're like 10, 12 people at this like random Airbnb in Denver. And we threw like parties or like events where we invited people from the industry. And she managed to even get some like VC sponsors and some companies to sponsor the event and throw their events and just teach us kids and try and get us hired or for different companies. So a bunch of people showed up at the actual Airbnb. And one of them was the Alongside team. Have you heard of Alongside before?
I heard of it because I looked into your background, but I hadn't heard of them much before that.
Did you also see maybe Universal?
No.
Universal Assets? Okay. So Alongside is this company that was building or still building crypto market indexes. So there's this like whole culture of like people who really like index funds, like S&P 500 style index funds, like the disciples of Jack Bogle, like one of the creators of index funds. And so the idea of Alongside is like, instead of having to place bets on individual assets in the market, just buy the whole market. So create an index that would represent the crypto market. And instead of having to place bets and try and see like, is Bitcoin going to do something, Ethereum or some other altcoin is going to do something, just do a market cap weighted sort of index fund of crypto assets and do that on chain. So that's sort of like the idea. And so I had known that team even before, and they had a job opening for like a junior engineer. So I joined them in February of 2022. So I left Morales, joined them as a junior engineer, because back then I was an engineer in like full stack and like Python land, but I didn't ever do any crypto stuff. As an engineer, I just wrote articles and did research, like vanilla research, not research. So I joined them and I was with them for like a solid 5 to 6 months. And I learned a lot. The reason why I left, the reason why we parted ways, is because I was essentially too unproductive for a startup. Like when you're a startup, you need to ship product, and they didn't have enough bandwidth to teach someone. Which, like at the time, like I wasn't that helpful there. But I still did learn a lot back then. Like I got interested into cryptography while working with them, because if you want to build a decentralized index fund, then you need to have like some set of computational, or like some set of nodes own private keys that would rebalance the assets like every day, or like depending to your strategy. So you'd have assets in certain wallets on different chains, like Bitcoin on BTC, Ethereum on ETH, like Solana on Sol. And you'd have to have nodes which would custody the private keys for these and would sign transactions to like buy and sell assets off exchanges, like decentralized exchanges or real exchanges, to rebalance the assets so that you'd have the market cap weighted representation of the index fund that you wanted. And so the original version of Alongside was centralized with like Coinbase custody. And the second one was like trying to be decentralized. So my task was like figure out, is there some way to make it decentralized? And so I got interested into like threshold signatures. There's these like Shamir secrets, threshold signatures thing. So that's like my original venture into cryptography. And I discovered also ZK through this and the L2 article stuff. So when I wrote articles, like my articles about L2s, I wrote about like Starknet, ZK Sync, Aztec, ZK VM from Hermes, eventually became Polygon ZK VM, and some other teams. And so I was curious about what this thing is. And so I started taking a course on ZK from this L1 called Harmony. I don't know if you remember. There used to be this like L1 called Harmony, and they did like ZK courses for some reason. And so I took a course on Circom, this like domain specific language for writing ZK circuits, and learned about basic ZK stuff. And so I knew that my next job, I would want to do more like cryptography things. This was like March through like June of 2022. And I still went to all the conferences that happened, so like after ETH Denver, we went to an Avalanche event in Barcelona. Then we went to DevConnect Amsterdam in 2022. There I met the Flashbots team. I became friends with the Optimism team. I met the Matter Labs team. They sponsored our hacker house there. So I met like Alex Buchowski and some of their cryptographers, some of their engineers. So I started applying for a bunch of these companies. I applied at Optimism. I applied at Matter Labs. I applied at, I think, Aave. I applied at just some of the people I met in person that I felt were good people that I could learn and grow with. And around that time, a month prior, my friend Miguel Piedrafita, purple hair guy. Do you know Miguel?
Yep. I've met a couple times. Yeah.
Nice.
It's been a while though.
So Miguel, the way that me and Miguel met, do you know Alex Masmesh?
I do know Alex Masmesh. Yeah, I do. Yeah.
So Alex was he's always doing like social crypto stuff. So the first company he founded was called Showtime, like NFT marketplace. And Miguel was the first hire at Showtime. And me and Miguel got introduced to each other by Alex at LisCon, the first ever conference I went to in Lisbon in October of 2021. And so me and Miguel became best friends upon meeting. I grew up in Spain. He's Spanish. So like we bonded over that. Plus we're in crypto. Plus we're same age, a little bit younger. And so we became really close friends. And he had met the world team in Lisbon, because Lisbon was the first ever location for orbs. And so he had met the world team scanning people in Lisbon, or orbing people in Lisbon, back when I didn't know anything about it, I felt it was like creepy. I saw them like with Miguel was like going over there. I was like, no, I'm not going. I'm not doing it. No, I don't like it. Which is like very, very paradoxical. But like he was like very open-minded and he talked to them. It was like, oh, this is like super cool. But he was still working at Showtime. But fast forward to like March, April, before Dev Connect, he ended up joining them. And so I was like, oh no, like why? I don't understand. Like you're smart. Like why would you make such a choice? And so he started explaining sort of the reasons of like why he liked the team. So like the whole like the privacy preserving angle, like there's the ZK side, there's the like just cryptography encryption, there's the whole like sort of ethos towards open source. Back then things weren't fully open source, but there is this like sort of commitment to making things open source. He sort of told me just how complex the orb was, like from manufacturing to like how complex the orb software is. Like everything's built from scratch, like all the hardware, the firmware, the biometrics, pipelines. He explained sort of the basics of how it worked. And then he told me that I should meet the world team at Dev Connect in Amsterdam. And so I met Remco and Philip, which are sort of like the lead engineers towards or for any of the crypto facing things still to this day, I would say. And so Remco he's like really well known in the crypto engineering sphere. His handle is Recmo, so like misspelling of Remco, RECMO. And so they start explaining sort of like technical side of the crypto stuff. So from the whole like how does the privacy preserving proof of personhood side works? Like you have this Merkle tree and you can prove an inclusion into a Merkle tree without revealing which leaf of the Merkle tree you are. I prove I have a private key to a public key in this Merkle tree without revealing which private key to which public key I own. And so this whole concept was like super fascinating to me. Like it had everything I was looking for. Like there is the cryptography ZK angle, there's like blockchain engineering, there's like Solidity and Rust. I was like Rust built at that time as well. I really wanted to write Rust. I really wanted to learn Solidity properly. I wanted to learn ZK. I wanted to work on a mission that I found interesting. And so I saw AI before. Like I knew that like image generation was going to be a thing. I knew that video generation was going to be a thing. I knew that bots were triggering me already. And that was like basic, like just vanilla, like pre-written answers and people just like spamming people on Twitter. So I saw the whole like why proof of person is needed angle. And then I also got sold on the fact that it was co-founded by someone who co-founded OpenAI, Sam Altman. So it was like it had the right backing, it had funding, it had a way for me to grow professionally, it had people that I looked up to. My best friend joined the company. I met the team. Everyone explained everything. They were super like open to explaining everything in detail. I spent like countless hours talking to them about stuff. I got invited to an offsite. I met the team there. I met Sam. I was like super flabbergasted. I was like a 20-year-old at an offsite, like meeting one of the people I had looked up to from a previous like interest, like the AI side, right? I was like interested in OpenAI because they wrote an agent to play Dota, and I was a League of Legends player, so I wanted them to do a League of Legends agent instead of a Dota agent. So yeah, that was sort of like how I got into Worlds. So I got invited into this offsite. I met everyone there, like most people from like the logistics, manufacturing, orb software, orb hardware, biometric side, the blockchain side, just the entire stack of people. And I met so many interesting people there. And so I was sold. At that point, I was sold on Worlds. And they told me that if I wanted to join, I can just try for a month and see how it goes. And so I took a bus to Erlangen. Erlangen is like a city in Bavaria, Germany, which was like the founding city for Worlds. It's where a lot of the founding members from Worlds come from, or Tools for Humanity, the founding entity of Worlds come from. Like Alex and Philip and Sandra and so many of the founding team members come from. And so I went to Erlangen, where the first office was, and I signed a 1-month contract with like if it was an indefinite contract with like a 1-month trial period. And so after 1 month, I was like super happy there, and I just ended up staying there until now, pretty much.
Wow. Awesome. Just for people, if there's some security experts who aren't quite up to what World is and what World's been up to recently, can you give like a 30-second overview of World and what you're building?
Yeah. So World has, I would say, like 3 to 4 main products, but I would start from sort of like the vision from why we built the things that we built, and then get into the things we built. So the sort of presumption is, if you extrapolate, the company got founded in 2019, 2018, 2019. So if you extrapolate the pace of progress of AI from back then, you could see that things like text generated by AIs, images generated by AIs, videos generated by AIs would become indistinguishable from reality, because the pace of advancement was just exponential. So if you sort of project the exponential out into the future, you reach a world where these things are true. You pass the Turing test across virtually anything. So you need to have a way to tell apart humans from non-humans or bots or AI generated things in the world. So that's like presumption number one. And it's a really important one, because you have this sort of like one of the negative outcomes of this would be the dead internet theory, where the user experience of the internet becomes so bad for humans that nobody wants to use the internet anymore, because they don't know what to tell apart from it. Like, you just don't know who is human, who's not human. And so like all the social use cases die. Like, all video games, you're playing against bots. All social media networks, you're talking to bots. Like, it's an echo chamber of bots. So this is sort of like one aspect. And the other aspect was, if agents or AIs start becoming economic agents as well, right? Like, they start solving problems, they generate economic activity, or they do economic activity, they produce value. Then the other question was like, who does this value go to? And how do you distribute value across people? And so there is this like also like financial network aspect to it as well. Like, how do you distribute value fairly that is generated by AIs to humanity, and how you build tools around that? So the company Tools for Humanity got started by Sam Altman and Alex Blania. And so that was the original premise. Build tools where you can tell apart humans from AI, and build tools where you can distribute value fairly. And so that's essentially what World is building. The first product was the Orb. The Orb is a hardware device which scans people's irises, and it's able to compute this thing called an iris code. You can think of it as a representation of the randomness of a person's iris. And this representation is unique for every single iris, for every single person. And if you combine both of these iris codes, like 2 per person, you have 2 eyes, you're able to essentially measure uniqueness per person. And with cryptography, you can make these iris codes private. We use multi-party computation for this. So you can make sure that every person has essentially like this unique pair of iris codes, and you can check that the distance or the difference between your pair of vectors or iris codes is different versus all the other pairs of iris codes for all the other users that are verified in a fully privacy preserving way. And if you pass this test, then you get a public key inserted into this Merkle tree for which you own a secret, or it's just the hash of a private key, essentially. We call it an identity commitment. And so you can then prove that you're in this set of verified humans without revealing who you are. So you can effectively, if you prove to the Orb you're a human, you get inserted into a list of verified humans, and then you can prove you're in that list. So this is what we call privacy preserving proof of personhood. And that's sort of like the second main product of World. It's called World ID. That's how the protocol or product is called. And the third one would be World App. So World App is a phone application or client for all the World things that we do, like World ID and the wallets and other things. And so World App is sort of this interface for mobile phones like iOS and Android that you can use to prove personhood, where you can like show the Orb a QR code, you get verified, and now you have a verified badge, and you can use cryptography like ZK proofs to prove you're a human to websites or to smart contracts without revealing who you are. I'd say the fourth product is sort of like an experiment, and that one is the token side, so WorldCoin. So now that you can prove you're a human, and you also have Sybil resistance. For those who don't know, Sybil resistance is essentially measuring whether someone or some human has only done something only once. So you can think of like a voting protocol, like we're doing an election, we're choosing candidates, and we want to make sure that each citizen only votes once. In the traditional world, we use like KYC documents, like your identity document, like your identity card. citizenship card or something. And you use that to vote. And that's you sort of like, you can only tally one vote per person. In the digital world, there's no such thing. And so you can use proof of personhood for that. Like for each person, for each proof of personhood, you can only do one action. And so that's also part of World ID. And since you have this primitive of like one person, only one action in a fully anonymous way, like fully privacy preserving end to end, you can do things like distributing assets fairly. So in the crypto world, we have known of airdrops since like the early like SushiSwap, Uniswap days, where like people got this token just from being users of a specific protocol. And we know that these things ended up getting like very botted. Like a lot of people did or programmed bots that would do volume on protocols and stuff to farm rewards so that they could get airdrops and like get economic incentives essentially and like attack economic incentives to get more value for themselves. And so this is called the so-called Sybil attack, where I can create multiple identities and manufacture sort of activity to get rewarded in a disproportionate way. And so we tried to also do an experiment in UBI or universal basic income, where we distributed we're still distributing our own token supply to all of the people that are part of the world network of verified humans in a fair and SIB-resistant way. So every user that downloads World app also gets a safe smart account, so a smart wallet on World Chain, which is our layer 2 on Ethereum. And so each user can claim WorldCoin only once per month and also on sign up. So we're fairly distributing the assets to every person that is part of the network. So it's sort of like distributing ownership of the network to each person that verifies. And it's also like an economic incentive to solve the chicken and egg problem of like the network is only valuable if a lot of people are on the network. Well, how do you make it valuable? Well, you need to have people on it. So the way you solve a lot of these like network bootstrapping problems historically has been through economic incentives. You know, like PayPal gave out $20 to everyone who sent money over PayPal through email back in the day. And they bootstrapped it off of eBay. Like there were a bunch of people who wanted to do payments on eBay and they didn't know how. And so PayPal like bootstrapped off of that. So we essentially bootstrapped our network through WorldCoin incentives. So those would be the four main products of World. The fifth product I mentioned is called World Chain, and that's mostly to service World app. So it's a layer 2 that uses the optimism stack. So it's an optimistic layer 2. Uses the OP stack, and it's on Ethereum. Those would be like a comprehensive summary of the main products we have.
Awesome. I want to kind of put you on the spot here. You said, when you're walking around with Miguel and you saw the orb, which is the iris scanner for the first time, you're like, yeah, I'm not doing that. I think I've walked around conferences and I see a lot of security researchers and myself who are also a little bit skeptical. How would you, now that you've been there for a while, how would you convince like a security researcher, hey, it's okay, you should do it?
I think a lot of us joined the space for the fact that our sort of intellectual curiosity was satisfied. So the distrust comes from not understanding, or a fundamental mystique. Like you not knowing makes it mystique, and it makes it scary. Like we are scared of things we don't understand as humans. So, and also there's like a lot of like culture, like, like there's a lot of movies where iris scanners are bad, like things like 1984, like Ready Player One, the CCP, modern CCP, like tracking and like social credit scores. There's a lot of good reasons to be skeptical of like biometric systems, and these technologies can be used for really bad things if you push it to the like negative limit of using these technologies. But at the end of the day, it's just technology. So the way I convince security researchers or people who are really technical and savvy and want to know these things is the whole like don't trust, verify side of things. Like if you have skepticism towards a specific thing, you can ask a question and I'm happy to answer, or you can look at the source code, right? So like the Orb hardware is open source, github.com/worldcoin/orb-hardware. Same for the firmware. Change the slug for orb-software or orb-core. Those are the two main Rust crates. Then there is the biometric side. You can go to open-iris, There is the cryptography side, the protocol side. So for all of these things, they're open source. So people can go and audit it themselves. They can go read the privacy audits from like Trail of Bits or from Least Authority or from Nethermind for different aspects of the code base. So security people like care about like security audits from firms they trust, or they can look at it themselves for specific things. The orb itself on the hardware level and the firmware level has like specific auditing mechanisms built in as well. So the SDK, the SD card in the orb contains the entire firmware, and the SD card in the new version of the orb is ejectable. So you can eject the SD card from a newly manufactured orb, and you can load it onto your computer, and you can verify like that the source code is matching a build from this open source repository. There's nothing added to it, for example. And you can like eventually have things like decentralized auditing, where like someone can like eventually like once like if you push these things to limit, you could have a system where like you can claim an audit through governance, and you can get the right to like eject an SD card, verify these things for yourself. Like currently we can just like let you, right? But like there's a lot of these things where like we're constantly pushing towards maximum transparency, maximum openness, explaining these things, trying to make it as open source as possible whilst not compromising on security. Just explaining how these things work from the orb hardware side, the firmware side, the protocol side, the biometric side, the cryptography side, trying to give a full coherent picture and just answer so many questions, and over time, I've done this a million times. I've worked at World for over 3.5 years, and I've gone to most conferences in that time. And so I've gotten all the like 1984 dystopian, like what you're building is evil pitches. And so it's always like a process of answering questions and getting feedback and improving, and eventually people come around. Some people, if they're not open-minded and they're not looking for constructive feedback, they just want to like trash the project. That those people like usually stay the way they are. But for those who are open, they at least come up later a little bit more open towards it. Like maybe they don't verify, but they maybe understand a little bit better. So the skepticism goes away. Maybe they don't want to get verified because they have no incentive to do so. That's totally fair. But other people get convinced and they verify and they become advocates. Also, the people who are the biggest naysayers, after they get convinced, they become the biggest supporters. It's also a very, very fun dynamic to see.
That's awesome. That's great to hear. I mean, there's so many pieces to what you're saying. Like there's different, 4 different main components, maybe a 5th one with WorldChain, a lot of really cutting edge technology with ZK and some of the hashing and all of that. What would you say are the biggest security concerns when you're thinking about WorldCoin as a project? Like what keeps you up at night on the security side?
So the security surface area that I'm most familiar with is all the protocol blockchain cryptography stuff. But when it comes to like a coherent picture, if you want to see the security surface area for the orb, well, it starts with the hardware, right? Like we use we use a trusted security chip. So we have a secure enclave and we have a trusted execution environment. So you're trusting the vendors, like the entire supply chain for that. There's like a custom operating system that is Linux based on the orb that sort of provisions a bunch of things. Like during manufacturing, you etch a private key into the orb, which then gets destroyed. And that sort of private key is the thing that authenticates it with our backend. So for all things like verification and stuff, like if someone theoretically is able to extract that private key from the secure enclave, they can do specific things within the operating system and stuff. And then they would have to like compromise the operating system, and the partitioning of memory and like specific kinds of memory can do specific operations within the operating system. So there's the like hardware security side. There's the firmware security side. Then there is biometrics attacks. So maybe you've seen things of like, if you apply a filter, like a noise filter on an image, you can fool an image classifier from thinking that an image of a dog is like a panda. And it's just random noise, indistinguishable to the human eye, but it can completely fool the weights of like an image classifier, for example. These are like adversarial machine learning attacks. So in our case, there's a bunch of these kinds of attacks. So like one fun example from the history of world is that when you're measuring the uniqueness of irises, what people would do before before this sort of bug was found is that they would do permutations of their left eye and the right eye of some different person. And so that combination of my left eye, right eye of a different person would create one uniqueness representation of iris codes that is different from just my both left eye, right eye. So people would do permutations of themselves to try and like verify multiple times. So this would be like an example of like machine learning adversarial attacks. And so the orb now has much more sophisticated and robust checks. There's things like there's a bunch of sensors on the orb. There's like infrared sensor. There's a time of flight sensor. There's there's an RGB camera. And so you're measuring things like you have a continuous 3D heat map, and which resembles that of a human. You're checking that the person is not wearing contact lenses or glasses, which may alter your iris pattern, right? So there's like anomaly detection models that would map like, hey, is this person wearing glasses or contact lenses? We have machine learning models that are trained on data sets of pictures of people with glasses and pictures with people of different contact lenses from different manufacturers, et cetera, et cetera. So that is like one surface area from like the hardware, firmware, biometric side. And then from the protocol side and cryptography side for us, the security surface area is, for example, for ZK protocols, the one that we use for proving is called GROT16. And that one has a trusted setup, right? So you're trusting the trusted setup done by the privacy scaling explorations group. Well, now they're called privacy, they rebranded on Ethereum. I'm forgetting the new name, but PSE within the Ethereum Foundation, they do ZK stuff. And so you're trusting the trusted setup they did plus the trusted setup that we did, right? So that's like another kind of security surface area. Like if you compromise that, you can manufacture ZK proofs. And so the whole protocol assumption goes out the window. You have solidity security surface area, right? Like if you have a bug in the smart contract, which allows you to verify invalid proofs as valid, and someone can somehow like spoof that, and the protocol like is able to pass an invalid proof as a valid proof, then the person can like double spend actions. You know, like they can claim multiple WorldCoin tokens. They can drain the entire supply of tokens eventually over time, because there's also like inflation limits. Yeah, they can break a voting protocol that uses World ID, or like we have an integration with Tinder that verifies Tinder profiles with World ID in Japan. So someone in Japan could like theoretically verify like 1 million fake profiles, which would break the Tinder integration, and then Tinder would lose conversions on their subscription or something. So that's like the protocol surface area. Or cryptography, you know, like there's the multi-party computation security, right? So if someone is able to break the multi-party computation protocol that we have for encrypting iris codes, then someone would be able to read the unencrypted version of iris codes. It's still not personal identifiable information, but it's derived from iris biometrics. So theoretically, it's like sensitive information as well. So there's a bunch of security surface area on like all of these sides.
Yeah. Oh, that makes a lot of sense. Is there any in particular, like, are there any security innovations that need to happen for World to be successful, or ones that, you know, are a little bit more cutting edge, or how do you think about it?
So one of the things that are like fun facts, we were the biggest security partner for Nvidia's embedded graphics cards, because we have an embedded graphics card. And the previous orb had the Nvidia Jetson NX. And so we're the biggest like contributor of CVSs for security filings for like Nvidia chips. So there's a lot of like things that we found where like we were using Nvidia chips to do things that traditionally they were not used to in different environments. So there's a lot of things that we had to do on that end. Like I wasn't working on that, but I overheard these conversations from like the firmware people. And so there's like things like that. We did contributions to like ZK auditing tooling. We did contributions to like traditional security tooling. A bunch of our engineers contribute to tools like Foundry, to tools like a bunch of the libraries like people use. We contributed to fuzzing libraries for like hardware like firmware components on the orb. We gave grants to a bunch of things that like improved security upon like different things. We contracted a lot of security companies, right? Like Trailbits, Least Authority, Nethermind, some others. So the things that need to improve, essentially, like the more complex of a system, the harder it's to keep track of all of these things. So I would say like the things that need to improve is like, like we also did like new things when it comes to formal verification of our ZK circuits. So we worked with a team called Ray Labs, and they built a automatic extractor where you could define a circuit in this programming or this library called Gnark, which is in Golang. And they wrote an extractor which would convert any Golang Gnark program, like ZK circuit within Gnark, to a formal verification circuit or like formal description of that circuit in Lean. So Lean is a formal verification language. And so we worked with this team called Ray Labs to build an automatic extractor for the circuit so you can formally verify those circuits. There's a lot of these things where like once you have a product needs and you're driven from like an outcome basis, there's like you identify surface area, and there's either real attacks or real possibility to like attack a specific thing, and then you start building security tooling for that. Yeah, I'm sure there's like a lot of other people which would be able to tell a lot of the cool parts from the hardware and firmware side. For example, like Ethan on the security team, or Adrian at Tools for Humanity. This is so many things that maybe I'm not as familiar with.
Yeah, that's awesome. And maybe we skipped a little bit there because I would love to hear what your role is and what you kind of focus on at World.
Yeah, so when I originally joined, I still have the same title. My title didn't change. It's research engineer. Before I was a junior research engineer. Now I'm leaning more towards like mid level research engineer on the protocol side. So I joined the Tools for Humanity protocol team, and the protocol team was the one, or is the one, that does all the World ID protocol related things. And now they also do a lot of the world chain stuff. So when I originally joined, I worked on the World ID smart contracts. So I did a lot of Solidity. That also faced with like ZK APIs, or like interacted with ZK APIs. Like I wrote I helped implement the interface for like a ZK verifier, or I did a trusted setup for the ZK circuits that we had. So I built some tooling for the ZK stuff that we did. I didn't do the hard cryptography stuff, but I wrote a lot of the harnesses and like testing tooling and integrations for the World ID smart contracts. I implemented the bridge for World ID from Ethereum to Optimism, because we migrated to Optimism before we launched our own chain. So I did a lot of like custom like message tooling to pass the state tree, the root of the tree for Ethereum from Ethereum to Optimism. So I used the custom Optimism messenger, and I built some like contracts around that to do like permissionless bridging of like the state from Ethereum to Optimism. And I just did a lot of like Solidity and then also Rust engineering. We have this thing called the sign-up sequencer. It's like a Rust service that bundles the public keys of people to be inserted into the tree. And once there is a batch, it creates a ZK proof of the state transition of the tree. So you prove to Ethereum that this is the new state of the tree, these are the new public keys, and compute the new root. And all of that happens in ZK. So I helped a bunch with the implementation of that in Rust. That was like my first year and 8 months at Tools for Humanity. And then I switched over to the World Foundation. So the World Foundation is a classic like labs and foundation split, where labs works on a lot of the like app engineering hardware stuff, and foundation works a lot on a lot of the decentralization ecosystem grants, some legal, some privacy stuff, and also some like road mapping things as well. And so I originally joined the foundation to work with external teams, and I managed the technical side of the grants program at the World Foundation. So we had an active grants program. It's no longer active, where we gave grants to third-party teams to work on interesting protocol or cryptography or hardware questions. And I was the one who was like awarding these grants, or like assessing the technical feasibility, and then working with those teams for those deliverables, like defining deliverables and then measuring whether those deliverables were met to sort of give up or to pay out a given milestone for a grant. And then eventually, once the milestones are completed, you do a full review, close out the grant. So I was like the technical lead for the grants program. And then I started working on some more like product facing things. I built, we had a collaboration with the government of Malaysia, or not specifically the government of Malaysia, but a specific entity called MIMOS, which is like a research entity that is part of the government. And we built a demo for like digital identity to prove you're Malaysian and over 18, so that you can claim a diesel subsidy. So essentially they have subsidized diesel or fuel. And if you prove you're over 18 and Malaysian, you can claim this subsidy. And the way they did it traditionally was like really painful and prone to abuse because people would drive up from Singapore, tank subsidized fuel in Malaysia, and then drive back. And so abuse subsidies that way. And so if you had a way to easily and in a privacy preserving way verify you're over 18, I built like a full end-to-end app where it's like a mobile app where you prove you're over 18 in Malaysian with ZK proof. A government service would then verify this on a blockchain that was like government owned. They use this thing called Hyperledger Fabric, like ancient private technology, like ancient like corporate blockchain technology. Sorry. So yeah, I built like this end-to-end product. This was like the original, my first like encounter with like AI coding editors. Like I was able to build like a mobile application in React Native without knowing anything about React Native. It was super fun. So yeah, I did that for a couple months, and that was already last year. And now I'm working on engineering. So I'm back to engineering, and I'm working on like a mobile benchmarking tool. So we're working now on client-side proving. So if you want to have privacy, you need to do all of the operations on private data at the level of the client, at the level of the user. And in our case, our users are in our mobile phones, right? So on World App. And World App runs on really bad phones at the tail end of it, right? Like if you look at the 99th percentile of the 38 million users, those users don't have good phones. And so if you want to do ZK stuff on bad phones, you need to make ZK performant on those phones. And if we want to ship a new feature in ZK that like is really computationally expensive, you automatically exclude those users. So we're working on a new library called ProofKit, which is, have you heard of Noir?
Yep.
So for those who don't know, Noir is a programming language for writing ZK circuits, a DSL that was built by Aztec, which is a privacy L2 on Ethereum. And so we're working on a backend for Noir. So same programming language, but different cryptography underneath, which is optimized for proving on mobile phones. And so now I'm working on a benchmarking tool that allows you to package any Rust function and automatically compile it to a mobile environment and deploy it to real devices through an API called Browser Stack. So you can benchmark Rust functions in real mobile environments so that if you have like a new PR for this like cryptography library, in our case, right? If you have a PR for this new cryptography library, you can benchmark it in real time in real devices that meet the sort of 99th percentile of like bad phones. And so you can see like performance regressions for like something that like is low memory, low like disk, low whatever, like low CPU. You can actually see real benchmarks, like how much CPU does it use, how much memory does it use, et cetera, et cetera, et cetera. So I'm working on that benchmarking tool right now, some other things. But yeah, that's mostly the, sorry, I'm trying to be fast because it's that there's so many things to cover. But yeah.
Yeah, no, you covered a lot. You covered a lot. I know we're kind of running up on time here, so would love to ask one on the AI side and then maybe a closing question. So on the AI side, you know, what are you seeing in terms of the biggest impacts for world now that LLMs are so much bigger?
So I think we've started to see the pain point. I think crypto Twitter, maybe you've seen the whole InfoFi thing, like Kaido bots. You know, like AI Kaido bots just destroying crypto Twitter. Thankfully, Nikita, like today or yesterday, published the like blocking these like InfoFi accounts. But anyway, the biggest problem I would say is like regular people being fooled with like fake videos of their loved ones. You know, like classical scams, like trying to ask for money. Then like content, you know, like you not knowing that who you're talking to online is a human, then playing against bots, matching against bots on social or like dating sites. That is like the regular thing. Like the three main verticals that World is targeting when it comes to consumer applications is gaming, dating, and social. Those are the three verticals that have over 1 billion users each and where proof of personhood matters in some fundamental way, right? And also video conferencing, arguably. So a lot of the products from World, the project, aim towards that, like solving problems in that area. So AI is making the experience in these products worse. Like also the business models are getting worse because if you have a bunch of AI views and you cannot tell apart the AI profile from the human profile, it's missed ad revenue. Like some advertiser is paying for views for a bot, not for a real human. So he's not getting to the person you want to. And so it's a lot of like just economic like waste. And there's a lot of it. There's so much of it. Because like hundreds of billions of dollars like per year worldwide of fraud or like just lost money to AI bots. And so as these business models like end up getting worse and worse, and the margins get squeezed, the more squeezed, and the user experience of the users end up getting so bad that they stop using these products in the first place. Like there's like real friction. That's sort of like the thing that actually sort of highlights the reason for why something like World needs to be or exists, and people start using it. Yeah, those are like the biggest drivers, like, and then on the sort of my personal thoughts on like where AI is like impacting at least me the most is like software development. So like as we start creating a lot more software and a lot more products, a lot more services, the economic growth of the economy, I think, is going to be like double digits. Same like what most people say, right? Like the US had like 5.2% like GDP growth, I think, year over year. And so eventually it's going to be like 10%, 20%, 30%. And most of it is going to be AI generated. So it's like going to be a lot of real questions about like welfare and stuff. Like who's going to benefit from welfare if people like start losing jobs and they kind of requalify faster than the agents like learn how to do something. They have robotics and all of these things. So in like the next 3-5 years, there's going to be a lot of that as well. But yeah, like when it comes to like current AI stuff, it's probably the whole like social gaming, dating stuff. And that's sort of like the verticals that we're trying to bootstrap our user base off of. Like solve issues for these kinds of companies and products and things.
Awesome. It makes a ton of sense. I see those use cases just exploding. So maybe you kind of answered this, but closing question, what are you most excited about in terms of what's next for you or what's next for World?
Mm-hmm. So for me at World, I just really I wrote this article about the future of digital identity like 2 years back, and I wrote a follow-up last year, like in December, November. It's called The Future of Digital Identity 2. And so a lot of the things that I talk about there is that we have a short window of time where we can make a lot of the products that we have privacy preserving, and the privacy preserving versions of these products need to have better user experience than the non-privacy preserving versions of them. And because of AI, we have this window to actually, like AI is the forcing function towards privacy, is my argument. And so if you build the privacy preserving versions of these products, you can create more economic value and have better user experience and just provide more value towards the user and for the service provider as well, if they're private. And so what I'm excited about is like having all this product, all this privacy tooling out there, right? Like this client-side proving library that we're building, that there's things like Aztec. I really want financial privacy to be a thing on chain with selective disclosure, right? Like if you have regulations, you can selectively disclose and prove to the like financial regulator that like these are legitimate transactions, but the balances do not need to be public towards everyone. So things like selective disclosure becoming mainstream, like instead of having my KYC documents being uploaded to X and then having the government being able to associate my tweets with specific things and then putting me in jail for like whatever, like freedom of speech kind of stuff. I feel like that those are things that are really important for me. So like if client-side proving and like these privacy technologies become mainstream and the mainstream world adopts them, we have a short window towards or for making these products a lot better and more private now. So that's sort of something that I'm excited for at World, like be part of the mainstream product that is private at the core, and people maybe not even have to care, but that's sort of like they care because the product is better, but it's private. It's better because it's private. That's sort of like what I want to make mainstream, and that's what I'm most excited about at World.
Awesome. Well, thanks so much for all the great technical details and all the different areas of World, and for going deep into your background. Thanks for jumping on the podcast. And
thank you.
Yeah, great.
It was a pleasure, man.
Yeah, it was a pleasure on my side as well. So thank you, and talk to you soon.
Awesome. Talk to you soon. Take care, everyone. See ya.